Hello and welcome again. This is Drew Rawlings and this is my second demonstration for my final project in embedded systems. For this demonstration I will show how to use the two SPI interfaces interchangeably to get functionality out of the VS1053b chip. This chip has several different test modes, and the one I will be using is the sine test mode. I wasn't able to find any speakers, but I do have it hooked up to my headphones, which you should be able to hear the sine wave when I have it up to max volume. So right now I have displayed on this oscilloscope the two slave select lines. Right here is the SDI, the serial data interface, and here is the serial control interface, and then the shared MOSI and serial clock. So right now I am talking to the SCI, since this is low, and I am telling it to write in the mode register and let it know that the test mode is on, or to turn test mode is on. So if I scroll over, now I need to let it know what test mode I want to run, and so this time the serial data interface goes low, and using these bits I signify that it needs to run the sine test, and this 8 bits here is the frequency I've chosen, which is 4/4. And some of the things that I found that were interesting or made it difficult when first communicating to this device was that if both these slave selects are low at any point, then it doesn't know if you're writing to the SDI or SCI, and it won't perform right. So that was important. Now if I scroll all the way back over to here, this is where I am actually changing the volume of the device, which I've demonstrated in previous. And so here I'm writing, and B signifies the volume, and then I have the left and right volumes. So now if I have it hooked up to potentiometer, I can increase it to or decrease it to its minimum volume, and as I increase to the maximum volume, you should start to hear a sine wave come out of my headphones like such. So now if I scan over to the current running to my device, since I have my max volume, it requires that more current is being used. But as I decrease the volume, it goes back down to its normal current draw. And this concludes my second demonstration